Okay, well, hello everybody. My name is Courtney Gallagher, and I am going to go a little bit maverick and present my screen. It should be up for everybody to see, so somebody shout out if you can. First, I'll thank the California Water Quality Monitoring Collaboration Network, that's a mouthful, for inviting me here, and especially to Eric. Thanks so much for the invitation to tell you all a little bit about Fishviews. I'm Courtney Gallagher. I'm one of the co-founders, and Eric introduced my history, so I won't bring that up. But yes, Fishviews was designed to be a tool for scientists, citizen scientists, decision makers, and the constituency to be able to collaborate, communicate with each other, and more than anything, bring context to data. As we go through some live demos, something you'll notice is it has a similar look and feel, and you'll get an idea that that we are similar to Google Street View, but for rivers, lakes, and shorelines. And that was by design to make it comfortable to use. Fishviews got started when our president, Brian Footen, who's a 20-plus year fisheries biologist from Washington State, really he just sat through one too many meetings, either thinking or hearing the words, if we had Google Street View for rivers, we'd be able to solve this problem. And Google has done a great job giving us information about roadways. We can travel all over the road, learn all kinds of information about the commercial entities and the businesses on the roadways, what time they open, whether or not people like it. But unfortunately, like in this shot of a street view on the Pacific Highway with the San Diego River below it, that information stops at the water's edge, or where the roadway ends. So that's where Fishviews was created and why Fishviews was created. The goal was, again, to have a place for aquatic data to live and help people use it and work with it and understand what it means. So let's take you on a tour of Fishviews. What I'm going to talk to you about today is give you an introduction of the tool, some of the basic features, and then move on to a few of the use cases and how the tool is being used today. So we're going to jump live into Fishviews right now, and welcome to the Guadalupe River in Central Texas. Yes, I know the actual Spanish pronunciation should be the Guadalupe, but if you're from Texas, you call it the Guadalupe, or if you're really savvy, you call it the Guad. So welcome to the Guadalupe River. Again, you get a similar look and feel to Google Street View when you jump on a Fishviews tour. You can click and move as though you're floating in a tube or a kayak. You can look around just as if you were in a tube or a kayak. Over on the right side of the screen, you'll see our survey path along the river on an Esri base map, because we are an Esri partner. And as you spin around, you'll also notice the arrow spinning so that you get a really good idea of where you are. It was important that we were able to stay oriented and know whether we're going up the river or down the river. You can also put your binoculars on as you travel up and down the river in your tube or your kayak, so that you can get a closer look of the shoreline. Now, if the tube is too slow for you and you want to go a little bit faster, you can put your motor on by jumping on what we call the float feature, and that just enables you to go a bit faster. It goes frame by frame, and you can just float along, and when you get to something that you find interesting, you can stop it, click out, and you will be transported to that area, so you can take a look at this strange debris up in the tree that showed up there after a flood about 4 months before this survey was taken. So that's some basic features about how to float along Fishviews. You can also go to different locations by jumping over here onto the base map, and you'll get a thumbnail at each location. If you see something that interests you, then you can just click on that location and be instantly transported there. As we go along the river, when we take our data and imagery, we also collect a number of water quality information pieces. Each what we call a scene, which is a 360-degree photo, will have that water quality information as well as the geographical reference. So we collect things like oxygen levels, pH, pressure, salinity, and a number of other water quality measurements. And each of those is going to be on every single scene, and it'll change as you go up and down. If you wanted to look across the entire water point to see if you could find an anomaly, you can bring up the graph, and it will show all of those pieces of information all the way up and down the waterway. As I move along this graph, you'll notice the reticle off to the right, the little red arrow moves along the waterway with you. So if you notice, for example, that the oxygen levels go up in a couple of places, you're able to go to that place, click on it, and see if you can find a reason. For example, here the oxygen levels are probably going up because you have the disturbance in the water. The same thing over here, as the tubers are going down what we in Texas call rapids, the mighty Texas rapids of the Guadalupe River. And so those different parameters are available along each of the waterways. For example, we'll go to the Elwha River in Washington State. This was one of the first rivers that we did, and we were really excited about it because we were on the water within days of the dam being completely removed and allowing the salmon back up into the waterway. So again, on this one I have pH selected. You can select a number of different parameters, but I have pH selected here, and again we'll see the parameters, and we notice that it's relatively stable as we go up and down, and then all of a sudden it makes a dip. It happens to be dipping right where we are, so if we look around and we find most likely the cause of that dip could be runoff from the roadway, rainwater runoff from the roadway that could be causing that dip in pH. One last tool to show would be if you are looking at this tour on your mobile device, and like a cell phone, and you happen to have VR goggles, we also have a fun little VR mode that you can go in here and you can look around. It's pretty fun to watch the kids put this on and actually float down the river. We'll take a quick stop here to see if there are any questions, and if there are not, then I'll go on to a couple of use cases.
Hey, Courtney, I'm wondering just what kind of camera do you use to collect this imagery?
We have a few different cameras that we use. We'll use a collection of GoPros. is what a lot of these pictures that you're seeing were collected by. We also have a Samsung camera that we've used. And then what we do is we go down with backups of GPS system, water quality system, and the 360 cameras. We fuse them all together as we're floating down the river or walking down the river. And then as we process it, we fuse all of that together. We can also include, and I'll show a little bit of that in a use case later, we can include some bathymetry information or even photogrammetry or LiDAR if those are collected at the same time or even collected separately as long as there's GPS information with it. Well, great, thanks. If there are no more questions, I'll go on to a couple of use cases and how the tool is being used currently. We will jump up to the North Fork of the Stillaguamish River up in Washington State. We were really excited to work with the Stillaguamish tribe because they came to us. They had a number of water surveys, a number of surveys of the river that they had done over a few years, had a whole bunch of data, but it was hard to use and hard to communicate because it was in tables and charts. They noticed that the scientists who knew exactly what the river was saying to them, knew what the problems and the solutions were on the river, they were having a hard time communicating some of those issues to folks on the Watershed Council who really cared about the river. They just weren't on it and didn't quite, as we like to say, understand what the river was saying. So we developed, in concert with them, we developed a way to take their data, which was all geo-referenced, put it into ArcGIS, and then pull it back out as a data layer into our system. So for example, if we clicked on the engineered logjam layer and they wanted to talk about this specific logjam that the reticle is pointing to, then they could go right to that point on the waterway, jump into it, and immediately start talking about that logjam while they're in the boardroom, rather than taking a big giant field trip and getting everybody's feet wet and going to the logjam itself. Another use case that's going on right now is in the Comal River. We're jumping back to Central Texas now. And the Edwards Aquifer Authority was really interested in helping educate kids in schools and the public about a number of the endangered and other aquatic species that live in the river, to help educate the public about why it's important to take care of the waterway. And so they contributed a lot of information. They contributed information in what we call our tag feature. And if you're signed in, then you can click on this little button right here and you can create a tag, and that tag can be available to just you if you're a fisherman and you don't want to tell anybody about your honey hole, or you're a scientist and you want to develop what's your theory and what's happening before you start to share it, or you can share it with a circle of friends, or you can even make it go completely public. And this tag that was contributed by the Edwards Aquifer Authority was designed to help the public understand about the fountain darter, and they uploaded a picture of it to show everybody what it looks like and talk a little bit about the habitat for it. And final use case that I'll tell you about is the on the Snoqualmie River. We did an experiment with them where we could take do a virtual survey of the river, and we took a look at the sediment on the river, where it went from cobble all the way to gravel. And in this one, we used the snorkel camera. Over here in the lower corner, we always have a single shot camera taking pictures as we go along, so each scene has one of those, has those photographs. We can put a 360 camera underwater, but usually the rivers are a little bit murky, so we just do the one shot so we can catch fish going by every once in a while. But this is an example of where we went from the small cobble to the gravel a few hundred yards down the way. So we are an Esri partner, and we showed you by going to the layers where we can take layers from ArcGIS and upload them into Fishviews, but you can also do it the other way. And this is a map of the of a mudslide, a 2014 mudslide in Snohomish County, and what we were able to do here is take the map where you're actually looking at ArcGIS online here now, and we're able to bring up an image from our trek, and even in the image in ArcGIS online, you can still spin around 360 and zoom in and out. This is in case you're already using ArcGIS online and that's where you're keeping all your data and you would rather stick with that. Another example would be this one also has the bathymetry information. This is the Willamette in Oregon. And this is an example of, we have a survey trek with the bathymetry, and this reticle here is where we are. I just moved it, and again, you can spin around by bringing the images into ArcGIS Online, and you can still spin and zoom as desired. So that is that's the end of the tour. The way we do collect it is we put this actually is a GoPro Omni on top that we use to collect the imagery here, and we can collect the imagery. It's fairly agnostic in either almost any kind of vessel, a kayak, a boat, and we have a backpack version right here, so you can just walk along the river if you can't get a boat there. And that's all I have for you. Are there any questions?
Yeah, I actually had a question.
Hi.
When you guys take the data, like the temperature and the depth data and the pH, do you have a standard way of doing that? You pick the deepest part of the stream bed, the middle, like how do you standardize that?
That is a really good question, and I wish that I wish that one of my cohorts, Brian, was here. I know we take the water quality meter along, and it's attached to the boat, so it's going to be where we can go. We will typically go down the middle of the river and the deepest part of the river if that's available to us. But that's the best I can answer your question at this point. I would have to refer to Brian, and I can get back to you to answer that more fully if you like.
Yeah, no, that'd be great. And I guess that question also extends to where you're taking photos, the snorkel cam. That's also just, I don't know, that's automated to the camera on the bottom of the boat?
Yes, we have the camera, and I'll click up to one of these early pictures. The snorkel camera can either be affixed to the boat, hard fixed to the boat, or we can, in this picture, oh, I'm sorry, you're not on the imagery, but we can also, so everybody else or anybody that's on there can see, but we'll stick it on the end of a pole for a single picture. So if there's something of interest that we really would like to get an image of, we can actually snap that specific image. But two, if for underwater either imagery or information, we can also put other collection devices, either sonar or another camera, to get information as well.
Okay, and I heard that you said you guys got data from a research team, and I was wondering, you know, when I worked with salmon and they came up with red surveys, I saw that you guys did have a layer to identify reds. Do you guys, if you have the data available, are you able to utilize stream bed characterization, like where riffles are and sediment type, and integrate that into your system? Or is that also part of, like, if I have that data, if I can get that onto GIS, I can...
If I understand your question correctly, are you asking if, as we do that original survey trek, if that we can identify the riffles as we go along?
Yeah, or if you integrate that from other people's data onto...
Okay, so I think the short answer is yes. We can integrate any geo-referenced data onto the tour using what we call our skin. So if you go through fishviews.com, we can integrate that data as long as it's geo-referenced, but then it also can be uploaded into ArcGIS and referenced that way. We have experimented with doing a virtual survey because we're taking imagery and data about every 3 yards. We are able to identify where riffles are, or deep pools, or other points of interest as we go along. So you can look for those things at your desktop as you're floating the river on the computer.
Oh, right. And then that leads me, sorry, this will be my last question for this. Does it tell you somewhere on here when the survey was done? Like when the images were taken?
It does on some in the each one has seen data, and that is where it usually is. So right now I'm back on the Comal River, and I clicked on the scene data, which is that little spreadsheet looking button, and the top line is a timestamp when that happened.
Oh, great. Awesome. Thank you so much.
Yes, ma'am. There it is.
Okay, great. Hi, everybody. Thank you, Eric and Courtney. Yeah, we're really excited about participating and collaborating in the Fishviews process, and I'll just kind of go over a bit of background about our organization, and then why we're involved in what we're planning on doing with the Fishviews data and program. So we're the San Diego River Park Foundation. We're down in the lower corner of the state. We're the second largest watershed in San Diego County. The San Diego River itself is 440 square mile watershed and a 52-mile long river. It's hydrologically disconnected from the upper watershed to the lower watershed by El Capitan Reservoir, where my mouse is on the screen. So that reservoir doesn't allow water to go downstream, so that we kind of treat them as two different systems. So the San Diego River, a lot of people don't know, but there was actually a San Diego River before there was a city of San Diego. And early European visitors to San Diego found that if the river was permanent, it may prove at time to be the best of all those discovered in California. And of course, we feel that it is. But in 2000, there was a 34 million gallon sewage spill on the San Diego River. It went unnoticed for a week, and at that time, it was the largest sewer spill in California's history. There was very little public outcry or care, and that's where the River Park Foundation was started by just a small group of individuals to bring a voice to the river. So malls had been built up against it, or it was there's a lot of private property around the river, fish kills, trash, other problems, but very little concern for what's going on in the water or around it. So again, as we started back in 2001 to support and empower community groups and those working on the river and foster stewardship of that asset. So here's, if anybody's been to San Diego, you probably stayed in Mission Valley. This is a photo from 1906, and can show you, this is where the San Diego River carved all of Mission Valley, so you can see it the river went where it wanted to in the floodplain. In 1915, here's another view. This is looking east. The river again was using its whole floodplain. And then here we go to 1960 when we started to get more development of the freeways and malls in Mission Valley. 2015, here's a view of what the river looks like now. It's mainly hidden behind the shopping malls and complexes, and a lot of people still don't even know the river exists. That's one of the things that in 2001 there were very few people who knew. They say, what river? That thing that floods. But now, we're trying to get more awareness that we have this amazing resource full of sensitive species right here in San Diego along the river. So to get people involved, one of the things that the River Park Foundation does is do volunteer-based citizen science efforts. So we started our water quality monitoring program in 2004. We monitor 15 stations along the lower San Diego River for general chemistry parameters, DO, pH, specific conductivity, turbidity, things like that, but only at 15 different stations, so not the whole length of the river. We also do invasive non-native plant surveys, trash monitoring, and look for homeless encampments. We do bioassessments looking for benthic macroinvertebrates at different locations, and we also have some headwaters programs as well. Our goal through our citizen science programs is to engage the public in collecting data, educate them, and also provide this information to decision makers, stakeholders, and the public so that they can know what the health of the San Diego River is. Here's some of our programs in action: bioassessment, water quality monitoring, and invasive non-native plant surveys that we're doing with our volunteers. Fishviews is a great fit to go into this program because we're building a San Diego River Discovery Center in Mission Valley in the heart of the river. This center is going to be a science education center, and we think that Fishviews and the data provided will be a great perfect component for the center, along with all of our citizen science, which will be highlighted at the center. So our vision is that we'll have the virtual reality headsets that Courtney mentioned and some big monitors, and people could take tours of the river using the Fishview data and learn about what's going on at different points in the river through that. Most of the river isn't that accessible, so this is a section underneath a 52 freeway, and people aren't going to be able to get there on their own, but it's absolutely gorgeous, and people should celebrate this and know what's going on. And we also want to know a little bit more about the water quality in these sections. One of the things that I think Fishviews can provide for us is information about stream shading and what that has to do, how that impacts water temperatures, dissolved oxygen, and water quality in general. The San Diego River is impaired for a few different constituents, but dissolved oxygen is one of them. And understanding the effects of stream shading on stream health, I think it's going to be a value that Fishviews can provide. Here's another section. This is another section in Mission Valley of the San Diego River. This is actually going to be undergoing invasive non-native plant removal, and on either side of the screen you'll see Brazilian pepper, Canary Island date palms. I think there's even some tamarisk in this photo. So over time, we'll be able to visualize the impacts of that restoration, and as well on different sections of the river, identify plants that do need to be removed that are invasive non-native along the river. So over time, through implementation of some of our improvement or enhancement or other agencies' improvement or enhancement projects, we'll be able to see some of the successes of that. So we just started this program with Fishviews just this year, and so Brian came out earlier in the year. Brian's the guy in the middle pointing to the equipment, and trained our volunteers. We're planning on using our volunteers, supported by staff, myself and a couple other folks here, to support them and help them kind of pick sections to go on, but you know, they're going to do the brunt of the work. So Brian came out and did a great training session for all our volunteers. What he's pointing at is the water quality multimeter, the handheld portion of that, and then this is the stick that would go in the water if you're on a boat. For the San Diego River, we have a variety of conditions where we have deep sand-mined pools, and so on those sections we can take a boat, and then on other sections we will have to walk, like in the other picture. So we're going to be employing a variety of methods to collect the river along Fishviews data. On top you see, this is one of our volunteers is the Omni camera, and then on top of that is the GPS unit, so that's where it is getting all the data from, so to geotag it. And here's one of we just have gone out in the past couple weeks and started to collect the beginning sets of data. Here's one of our underwater shots. I thought was kind of neat. It has a little anurin down here, a little chorus frog tadpole in the water. And just, you know, this is the kind of information that can connect people with, like, this is a beautiful scene, and there's so much to explain in here, from the algae to the willow roots to the chorus frog. This is something that provides an avenue to really explain and have people explore the river and feel connected, even if they can't go and touch the water because it's cordoned off in some areas. So we're in the process right now of collecting data. We'll maybe take a little hiatus in the middle of the summer months. We'll see how it goes based on how much water is in the stream and the areas we're trying to connect. And we can't wait to work with Fishviews further on it. So if anybody has any questions, I'd be happy to take those right now. Thank you.
Can I ask a quick question? Sorry. I was curious how long a section you're planning on doing this of the river. You're going to do this work, and how long do you expect this to take?
We're hoping to do about 20 miles to start with, and what we're finding is different sections take different amounts of time. For instance, we did one a couple weeks ago. We got 2 miles done in, you know, a couple hours, maybe 3-4 hours. Some of the sections are a little bit harder to do, and we got a half a mile in 3 hours. So I think that had to do with, you know, being in the boat versus walking on the shore in stream. But our goal is to kind of get all of our preliminary data collection done through, you know, by winter this year. So hopefully we'll get some kind of nice water shots and some streams that are actually full through like November this year.
Okay, thanks.
Mm-hmm.
And I do see a couple questions pop up in the, this is Courtney, sorry. I do see a couple questions pop up on the conversation list. One was, is the date listed for the time of the data? That may have been typed in before it was asked earlier, but yes, there's a time stamp on each of the scenes that would have the date and the time that it was collected. Another question is, what's the minimum water depth that that Fishview can be used? That's a great question. There's not really a minimum, as depending on what information you want. If you have a if the water quality meter sensor can't be submerged, then you would not be able to get the water quality data, and the depths could affect the accuracy.
Courtney,
on
the other
the,
thing I thought
oh,
the
sorry.
other thing I thought I'd mention is that it's Shannon. For the pressure transducer, so you can do depth measurements. That was one of the things we had talked about. You could add bathymetry. So that one, I think that one has a limitation of it needed at least a meter of water. So in some sections we weren't able to use that, but we were able to do water quality measurements in less than a meter of water. I think about a foot is what we were doing.
Okay, great. Thanks, Shannon. And then Helen Thompson also asked, does the timestamp refer to the other data? Yes, the timestamp does refer to when the information was collected, and that information is a snapshot. There is also the capability of linking in live information. I know Shannon was talking about 15 different monitoring stations that are up and the water quality meters that are up, and those can all be connected into the tour and linked to for real-time data as well.
Yeah, I had a question. It's Annette again. I was wondering if you guys have some sort of system set up that you're going to be mapping different waterways, or kind of like Shannon, she got trained and they're going out to map their river. How does that work?
No, thank you for asking that question. There are a few different ways that that waterways do get mapped. Some of them we will just go out and map. You'll notice there's a concentration of rivers in central Texas and up in the Seattle area because that's where the folks that are in Fishviews live, so we can get out there and we can map those a lot more easily. We have two different ways that we go out to map a river. One is called We Map It, where we are contracted by an entity to go out and map that waterway. And another option that we have is our You Map It, which the San Diego River Park Foundation is the first group to go and do that. So we're very thankful that they're here to go do that. But that's where we hand the equipment to that entity, and they go and map it and send it to us for processing and to publish on the website.
Okay, and in those scenarios you do provide training, so there's some like standardized way to map these waterways, or?
Yes, we do provide training to the folks, to the entities that that are going to take the equipment.
Brian had come out and he did, this is Shannon again, he had done an initial scoping, and so he actually went along the river and provided recommendations about how we might map certain sections of the river and what equipment we could use in a certain section based on depth or vegetation type. So he was able to provide some really great expert advice on how we might cover some of these areas.
Okay, that's great. And then on average, how long does it take to do like a mile?
This is Courtney. That's difficult to answer because it all depends on the waterway. An open lake, we could do 20 miles of shoreline in a day with a boat that has a motor on it. But if we're walking, especially if it's difficult terrain, then it could take a few hours to do even a mile. So there's a wide range, and it would completely depend on what the terrain was.
Okay, yeah, that's helpful. Thank you so much.
Thank you guys so much for your questions.
Yes, I have another question. I wondered if you have worked on streams where you've had multiple owners of the streams and you've had to deal with getting permission to be on different sections of the river?
This is Courtney. We have We have worked with multiple groups to get a waterway mapped. So far, the waterways we have been on, you have right of navigation, so we were allowed to be on the waterway without having to ask specific permission to be on it. If we did have to get permission to be on a waterway, then we would certainly have to work with folks to grant that permission. But so far, it's been navigable waters that we could just be on.
Okay.
And then in San Diego, I mean, yeah, the river is a public trust, but a lot of the times access may be on private property. We have relationships with a lot of the landowners along the river, so those that we have relationships with, we're going to be moving forward with mapping those, but there are some properties that we will have to skip because we don't have permission and the access might be through a private property owner. But hopefully, you know, later on this is something that where we can always come back and do that in the future if we can, if the landowner changes or if the relationship with the landowner might change.
And this is Courtney jumping back. You know, certainly that would all of that would be part of the scoping process to find out what kind of permissions. We do have one lake that we had to get some very specific permission to get on there because it was a highly protected lake called Spring Lake in Central Texas. Eric, thanks a lot, and thank you to everybody who participated today. This was a lot of fun.